So here we have the second question. Design a 4-bit full adder and subtractor and simulate the same using basic gates. So here's our full adder circuit design. It consists of 2 XOR gates, 3 AND gates and 2 OR gates. So there are 3 inputs, A, B and C in respectively, and 2 outputs, that is the sum and the carry out, as we can see in the truth table over here. So if all the 3 inputs are 0, the carry out and the sum will also be 0, and if the carry in is 1 and A, B, the 2 inputs are 0, then the sum is also 1. Same goes over here. When one of the inputs is 1, the sum is 1, and when 2 inputs are 1, the sum is 0 and the carry out is 1. And when all the 3 inputs are 1, both the sum and the carry out will be 1. So here's the representation, and here's the expression for the sum, that is A dash B dash C in plus A dash B C in dash plus A B dash C in dash plus A B C in. The simplified expression is like S is equal to A XOR B XOR C, and for carry out it is AB plus ACN plus BCN. So here's the full subtractor circuit. It's similar to the full adder. There are 3 inputs, that is X, Y, B in, and 2 outputs, that is the difference and borrow. Similar to the full adder circuit, there are 2 XOR gates, 3 AND gates and 2 OR gates, and the output goes like, if all the outputs are 0, then the borrow out and difference will be 0. If the borrow in is 1, then if one of the outputs is 1, then both the borrow out and difference will be 1. And if both outputs are 1, then the borrow out would be 1 and the difference would be 0. And when all the outputs are 1, then the borrow out and difference both are 1. So here we have X is 1 and borrow in is also 1. So if that's the condition, then borrow out will be 0 and the difference will also be 0. Here's the visual representation of that. So the expression for difference is x bar y bar b in plus x y bar b in bar plus x bar y b in bar plus x y b. Simplified expression for difference is x XOR y XOR b, and for borrow out it is x bar b in plus y b in plus x bar b.